So in this diagram, ABT is a circle, center O. PQ is a tangent to the circle at T, and ABC is a straight line. TC bisects angle BTQ. Angle BAT is equal to 44 degrees, and angle PTA is also equal to 60 degrees. So in this question, we are asked to find angle ACT. All right, so this is the diagram we have. So let's quickly look at how we can look out for what this question demands. So in this question, we are seeing that PQ. So let's see PQ. Where is PQ? So this is what our PQ. So this line here is PQ. And what does the question say? So the question says PQ is a tangent to the circle at what? T. So if we are saying that PQ is a tangent to the circle, and also we have ABC as a straight line. So this is ABC as a straight line. So this line is a straight line. Now looking at this, you see that we have an angle formed here, which is what, 60 degrees. We also have 44 degrees here. So once we have these two angles, then, and this question also says PQ is a tangent to the circle at T. Now looking at this line here, T and B, so from T to B, now this line is what we call what? A chord. So this is a chord. Okay, if this is a chord, then TA is also a chord. And for circle geometry, looking at this theory or this property, whenever we have a tangent line to a circle at a point, if we have a chord, then we are saying that the angle formed between that chord and the tangent at the end of that chord is equal to the opposite angle at the alternative angle. That's what we are saying. So if we are saying this is a tangent line and this line here is also a chord, then we are saying that this angle formed here, the angle between this chord, so this line is a chord, and we have the tangent line here. If that is the case, then the angle formed between that chord and the tangent, we are saying that it is equal to what? The opposite angle at the other what? Angle formed at the segment. So looking at this angle is what? Opposite to this angle. That is what we are talking about. That's what this property what says. And at the same time, we have 60 here. If the same theory or property holds, then automatically we can also say that this angle here is opposite to this angle, because this is the angle formed between the chord, because we are saying that this TA is also what? A chord. And if this is a chord and we have this as a tangent line, then the angle formed between this chord and the tangent is equal to the angle opposite to what? The segment, the other hot segment. And looking at this angle is opposite to this angle, so it means that automatically here is also what? 60 degrees, right? Okay, and then here is also what? 44 degrees. If we can conclude that this angle is equal to this angle formed here, and this angle is also equal to this angle formed here, then since we have 60 here and we have 60 here, then we can quickly look for this angle, this particular angle here. Now, since P PQ is a tangent line, it's also a straight line. So you can see that this angle is formed on a straight line. Once you have angle formed in a straight line, then you have to recall in plane geometry 1, we said that angles formed on a straight line gives us what? So the sum of angles on a straight line gives us what? 180 degrees. Remember, we've already done this in plane geometry 1, so whenever you meet such theory, you should understand. So once we know that if we sum all these angles, we are getting 180 degrees, then we can quickly find what? Angle ATB. Angle ATB. So we can see angle ATB is equal to, so it means that we are adding the whole of these angles, and then we get 180 degrees. So we get what? 180 degrees minus, because at the end of the day, if we sum this out, we need to take away from what? 180 degrees to be able to get this angle. Have you gotten that? Good. So we are getting 60 degrees plus 44 degrees. So this gives us 180 degrees minus 100 and, so we get, so this plus this gives us 104 degrees, and then angle ATB is equal to, so we are getting here as what? 76 degrees. So it means that this particular angle here is also what? 76 degrees. Good. So once we know this, here as 60, here as 40, here as what? 76 degrees. Then we can proceed and look for the next question. But we shouldn't also forget that in the question further said TC. So where is TC? TC bisect what? BTQ. So where is BTQ? Now this is B angle what? BTQ. So it means the whole of this angle, which is the 44 degrees. So once we are saying that TC bisected, it means it divides the angle into two equal parts. Have you gotten that? So if TC divides angle what? BTQ, then we can say that this part here is what? 22 degrees, and this part is also 22 degrees. So we can write 22 here and then 22 also here, because the question says TC bisect what? BTQ. Good. If we've arrived at that conclusion, then we can move on. So once we know here, we know this angle, we know this angle. Now we have been able to what? Identify all the angles in the diagram. Then we can proceed to find angle ACT. So angle, let's see angle ACT. So where is angle ACT? So angle ACT. So we are looking for this whole what? Triangle here, angle ACT. So let me quickly draw that angle so that it will be easy for us to work out. So this is angle ACT. Don't mind my diagram, it is not drawn to scale. So we have here as A, and then here as T, and then we have C. But we know the angle at A as what? Here is 44. Okay. but we don't know this angle. That's what we are looking for. And angle T, the angle at T, that's where we have calculated. So let's see. So this from this portion here, from here to here, that's what we are looking at. So we calculated and we got it as, so we got here as 76 degrees and we got here as 22 degrees. Have you gotten that? All right. Once we have here 76 degrees, 22 degrees, and here being 44 degrees, then it becomes so easy for us to find angle what? The angle at C. But how do we find the angle? Looking at this is what? A triangle. And you know that the sum of interior angles of a triangle is equal to what? 180 degrees. So this one, we can quickly write our answer as, so angle ACT plus angle, so we have ACT plus angle TAC, so TAC plus angle, and then we have ATC, which should be equal to what? 180 degrees. Okay, all right. So angle ACT, which we are interested in, plus, so angle TAC, what did we get? So what do we have? Let's see, angle TAC. So ATAC, this is the angle we are looking for, which is what? 44 degrees, right? Let's look at angle ATC. So angle ATC, that's where we have what? The 70. So 76 plus 22 degrees. That's for the whole of what? ATC. Good. Which is equal to 180 degrees. So if we work things out, then we are getting here as angle. So angle ACT plus. So if we add all of this, we are getting what? 142 degrees, right? Which is equal to 180 degrees. If we find the additive inverse, then it means that we are getting here as angle ACT, which is equal to 180 degrees minus 142 degrees. Therefore, we get angle ACT as 38 degrees. So this answers the entire question. Very simple, isn't it? Yeah. So questions like this, you need to take your time. It's not difficult. Most of the time, students meet such questions and then they will find it so difficult to go about this question. But you see how I solve it. Very simple, right? Okay, so my name is Evans. Okay, that's your facilitator. This channel is Mazris TV. Please, I will want you to subscribe to my channel, like, and share the videos. If you have any question, you can also go to the comment section, write your question there. You can also add any submission. We are all learning, okay? So you can bring your submission and look at it. So see you next time. Thank you.